Good morning.
Good morning.
Welcome back. Today, for lecture, we're going to be reviewing Hashketball, a lab that everyone here should have completed. We probably won't get through the whole thing. We've only got an hour slated for this lecture. That's okay. Now, you all should have solved Hashketball. Here, we'll be more focused on the thought process that I have and the problem-solving techniques that I might use to try and tackle something like this, right? So I'm just going to dive in, but please feel free to stop me at any time with literally any question that you have. Cool? Okay. So first things first, we've got Hashketball. The file starts out like this. We're requiring pry at the top, which means we can binding.pry. How many folks in here are using binding.pry to try and help debug things? Okay, about half. We want to get more comfortable with binding.pry this week. But part of that means figuring out when it's a good time to use it and how to use it. So I'll try and talk about that some today as I'm going through things. In this file so far, we've got require pry, and then there's some game hash method here, which just returns, oh God, this thing, just returns a giant honking hash, really a very, very large hash. And then underneath that, we've got a variety of different methods, some of which are commented out, like num point scored right here. Which seems like as good a place to start as any. We also, of course, have some tests. So test-driven development is a very common thing in programming, both here at Flatiron, especially with the labs, and more generally. We can run the test by using the learn command, or we can just use the rspec command and tell it about the spec folder. And then it runs, and we see a ton of different test failures. Now, when we're using test-driven development, a lot of programmers talk about red-green refactor. Have y'all heard about red-green refactor? Okay. So the idea of red-green refactor in test-driven development is that if you have tests, you want them to guide you in terms of the code that you're writing. You don't always have tests in industry, and you don't always have tests at the Flatiron. When we give you exams every 2 weeks, those don't have any tests provided, so you just have to test your own code as you go. We'll talk about how to do that some as well. But when I have test failures, they give me pretty good ideas about what's going wrong. Now, we go through a process in TDD that's called red-green refactor, which is if you have a test failure, you've got some red. What I want to do is I want to get that red to green, get the test passing. Once they are passing, I'm free to rewrite things. So if I'm trying to get to green, I'm happy to make as big a mess as I need to just to get the test passing. At the point at which they are passing, I can step back and say, well, I got the application to work. Maybe now I can think about how to clean things up and write the code in a nicer way. But my immediate goal is to get things functional. That's my immediate goal. So that's what red-green refactor is about. So right now I've got a lot of red, but me as a programmer, if I try and think about all these different problems at the same time, that's not that helpful to me. So I like to use the fail fast option to rspec. That looks like this. You can also use that option with learn. If I say learn fail fast, no. I haven't installed the gem. Right. I won't do the learn command right now, but you can also do it with learn. We can just say fail fast, if I can type it. And when we do fail fast, it doesn't show me every test failure. It just starts running the tests, and we see all the tests that pass up here in green, right? We get a little green dot for each passing test. And then as soon as a single test fails, it stops, and I see the failure. Here we see, let's talk about reading this error message and what we can take from it, just before we go any further. So first of all, I see what kind of exception this was, right? This was a no method error. That's the kind of failure that I got. And it's telling me specifically that the num point scored method is not defined, and I'd expect it to be. So how would I fix that? Define it. Def num point scored. That would be my starting point, right? That would at least get me to a different error. The other thing here is with rspec, I'll get some textual description of what the test was checking for. So there's supposed to be a method, num point scored. It's a common convention you may have picked up on that we prefix method names with the pound symbol or the hashtag, whatever, this thing, right? So when I see num point scored here, it's telling me that method should know the number of points scored by a particular player. But in terms of, like, as a textual description, that tells me in English what the thing's supposed to do, or what the test is checking for. This expectation line can be pretty helpful, the failure error line. This is telling me how the test actually ran the method to check it. So I see that it ran num point scored. It looks like it passed in the string Jeff Adrian, and we were supposed to get back 10. I don't know what we did get back. Well, yeah, I did. We got no method error. So that's our problem. Okay. So to fix this, the simplest thing I can possibly do is actually just uncomment this method definition that was actually very helpfully already put in the lab. Thank you, lab writers. So we've got def num point scored, and it looks like it takes an argument of a player name, which is probably fine. And then I'll run rspec fail fast again just to see that I get a different error or a different message, and I do. Now I'm seeing something different. Yes?
What was the hotkey to uncomment that?
The hotkey to uncomment that. Great question. These are things, that's a fantastic question. I totally forget these kinds of things. I forget to annotate, like when I'm using my editor, what I'm doing sometimes. Please do ask. Also, you might not be using the same editor that I am. I know a lot of people like VS Code. I used to use Emacs. I've used them. Like, whatever you're using, it's totally fine. I highlighted this region, and to bulk comment, uncomment, I do command and /, and then I can toggle the comments on or off for a block of code. Great question. What's your name?
Han?
Han, thank you. I'm trying to learn names. It's going to take me a little bit. There are 19 of you. It's awesome. And now I'll sip some water. Okay, so I'm no longer getting that no method error. Now I've got a little bit of a different situation. It says it expected to get a value back of 10, right? We expected that calling num point scored with Jeff Adrian would return the value 10, but instead I just got back nil. Why did I get nil? Yeah, there's nothing in the method. The method's completely empty, and when we have a Ruby method that just doesn't really do anything, by default it returns nil. Okay, but I've got some pseudocode here. It says first we should get a list of all the players, then we should find a player whose name matches the argument player name, and then we could just return that player's points. And I think that sounds about right. So let's try and do that. It seems like a pretty good strategy. Getting a list of all the players. Now, right now, the only thing I can access to get the player data is this game hash, and boy, is this thing a doozy. When I'm thinking about working with or traversing a big nested hash like this, there are a lot of different ways to do it. You can use nested loops with like each, and then you really need binding.pry to keep track of what you have at different levels of the hash. That's not necessarily the only thing you could do, but I want to try and map out hierarchically kind of what this hash looks like. I just need to stare at it for a little bit because as a programmer I haven't done that, and if I don't know the shape of the data, I'm going to have a hard time manipulating it, hard time interacting with it. So we've got some hash, and then it has a home key, and then, I don't know, there's a whole bunch of other stuff after the home key that I don't care about right now, so I'm actually going to just snap that closed. Then we've got an away key. Great. So I've got home, and then somewhere down here, I've got away. Okay? So both of those are subhashes. So I'll do that. And that, and that, and that. That seems about right. We've got one more, don't we? Okay. Also, my squiggles and scrawls are basically indecipherable to anyone but me. If you can't read my handwriting, let me know and I'll try again. Might not work out, but we can give it a shot. So both of these hashes look like they've got about the same structure, which is really nice for me. That means that if I can just kind of figure out how to deal with one side, I'll probably be able to use that to work with either side of the hash. Both of these keys have a team name, or both of these hashes, I should say, subhashes, have keys including a team name, which is a string, and then colors, which looks like some kind of array. And then we've got players. Oh dear. And players is some other subhash where it looks like the keys are strings of player names, and then it maps to a hash of attributes, kind of like the information about each player, stats. So that's unpleasant. All right, so what I would really like to do is I would really like to get a list of all the players, because I'm not really interested in home and away. I'm just interested in players. In this situation, I don't care about which team they're on. I'm interested in finding a player in general. So there are a couple different ways we can think about that. There are some sort of sub-problems here. One is I have to be able to dig into this hash deep enough to get the player's sub-hash out, right? I've got to have some way to get that information. Then the thing that's immediately coming to my mind is, is there a way that I can take two hashes, this hash of the home team players, and then this other hash of the away team players, and is there some way that I could put those together? Is there a way to combine hashes? Because if I could do that, if I could just say, give me the home team players, give me the away team players, put them together, then I've got a list of all the players. To me, that seems like the most natural thing to do. We got to figure out if that's an option, though. And we've got to actually figure out how to get to that information. So I'm going to try that. I'm going to throw a binding.pry right here. There are two different ways you'll see me use binding.pry when I'm programming. Sometimes I want to use binding.pry to experiment with a particular piece of data. I want to get some data structure or some variable in the program and just kind of play with it, throw methods at it, see if I can get to the information that I need using it, right? See if I can manipulate it in a way that's helpful. Other times I use binding.pry to just check calling a method manually and passing it some argument to see if it does what I want. Those are kind of the two cases you'll see me use binding.pry probably. This is the former, right? I'm going to put a binding.pry inside num.scored. I'm going to run the tests. The nice thing about binding.pry is that as the program runs to this point, it will eventually reach the binding.pry and freeze. And then I'll get some prompt where I can enter in whatever code I want and see what happens. So it gives me a good way to try things out. So I'll come back here, run rspec fail fast. Then I'll hit our binding.pry. I'm inside the num.scored method. First thing I'm going to check is see that I can get the game hash, and I can. But it looks like I'm stuck in this window. Has anyone encountered this problem before?
Yeah.
OK. So this happens when your terminal is trying to show you something that's too big to fit on a single page, basically. You enter a sort of pager interface, which under the covers is sometimes the program, the terminal program less. And the important thing to know is that you can scroll up or down. You can actually search, which is kind of cool when you're in this interface. If you hit the / on your keyboard, you'll see at the bottom, you get a little / right here. And we could check for, I don't know, points, for example, and it will find some nearby instance of points. But the most useful thing to do is eventually after you've paged around a while, you want to leave this thing, and then you just hit Q. And when you hit Q, you get out of less.
Yeah,
And then you are free. You are out of less. Okay, so that's when you're in that, that's if you're in that scrolling interface though. If you're in binding.pry, note that I'm still in my binding.pry. So I've got this game hash, and I know that it has this key home. What's the normal syntax that we use? Everybody on your whiteboards, I want you to write for me the syntax that I would use to get the home information out of the game hash. I'm going to start a timer. We will have 30 seconds for that. 30 seconds on the whiteboard. How do I read the home key out of the game hash? All right, 10 seconds. 5, 4, 3, 2, 1. Markers down, whiteboards up. Okay, great. So if I have a key and I know what the name of that key is and I just want to access it directly from the hash, I can do this, right? This is kind of the answer I was expecting. We're going to look up the game hash, and then I'm going to use the bracket syntax and just write in the value of the key. And in this case, the key is a symbol. We can tell that by looking at it here visually, right? I see home : that's a symbol data type in Ruby. Some of our other keys are strings, but these are symbols at least. And so if I want to write a symbol, the colon actually comes at the beginning. So I'll say : home, and then I get the home hash, like this. Okay, but that's not good enough. I need the players. So back to the whiteboards, 15 seconds. This is going to be a really fast one. How do I modify that line of code I had before to now get the subhash of players? 20 seconds. We'll say 20 seconds.
If you try to do it without the colon, what happens?
If you try to do it without the colon, what happens? Ask me that again in just a second. It's a great question, Keisha. 5, 4, 3, 2, 1. Markers down, whiteboards up. Yep. All right, great. They're basically all in the same place, right? Once I've got the home key, I can just continue drilling down. I can say, okay, now the thing I want is the players. And now I just get that subhash, right? I've now got the home players. So I think it would be perfectly reasonable for me in my num.point_scored method here to say home players is game hash home players like that. And now I've gotten the home players, and probably I imagine I can do exactly the same thing to get the away players, right? It's just a different key. It's the away key instead of the home key this time. And then I go back down and get the players again. And now I should have been able to get both of the hashes for the different players that are available, right? Let's test that out. I can try that. I can now exit my pry. The tests run. We hit some test failure. I can now rerun rspec. I wind up back in pry, but now I can double check and make sure that those variables were defined as intended, and now I got the data that I wanted, and it looks like I did. Now, Keisha, you had a really, Rose, you had a very good question earlier. What was it?
What happens if you try to pull up that part of the hash without the colon? You try to call it something.
Without the colon. So Keisha says, what happens if we remove the colon? Can anybody tell me what happens if we remove the colon?
It
Yes.
thinks home is a variable name, not a symbol.
It thinks home is a variable name. That's right. So it assumes Ruby's evaluator says, okay, I'm trying to access a hash, but I'm not sure what home is. It doesn't look like it's a string because it doesn't have quotes around it, and it doesn't look like a symbol because it doesn't have a colon in front of it. So it must be a variable or a method, a local variable or a method. And I'll try and look up the value of it and use that as the key to drill into the hash, except that variable is not defined, so we get a name error.
If we had built the hash with home as a variable, then it would be fine.
You cannot, you cannot write an object literal, or like a hash, like written out the way that we have here, with a variable name for one of these things. If you do, well, I guess you could do this. So let's talk about what that would look like. If I have a variable dog, and it's the string Jürgen, then I could write a hash, for example, that is dog, or like, dog naughty. This is a hash that maps dog names to behaviors, and in my particular case, Jürgen is a very naughty boy. So if I define it this way, then we'll now have some variable example that gets defined. But if you look at how that evaluates, when Ruby's reading that in, it's got to make some kind of decision about how to do that, right? So it reads the value of dog at this time, and then constructs a hash with that key, his name, Jürgen, associated with naughty. Now, if I change the value of the variable, if I now say dog is cookies, I don't know why I use cookies as an example for literally everything, it doesn't modify the hash at all. There's no connection between the hash and the variable such that when I update the variable, the hash is updated too. So
this will just cause problems and confusion pretty much.
Right, so basically my advice there is using a variable to figure out what to look up out of a hash is fine. Using a variable to put things into a hash can be kind of weird. Using a variable name as a key in a hash when you're building the hash probably will lead to confusion. Not a common thing to do. Good question though. The more important part of that to me, at least personally, is that if we try and do this sort of thing, Ruby's going to look that up as a local variable. And this will only work if I have that somewhere nearby as a local variable. That's the important part of it to me. Good question. Other questions? Okay, cool. So we've been able to pull out the home players and the away players, and that seems great. The problem now is I want to see if there's some way that I can combine them to get, all the players. So the question is, can I combine two hashes in Ruby? I think there might be a way to do it. Show of hands, anyone would like to tell me the method I can use for that? Rami?
Yes.
And is it Andrew?
Yes.
Keep him working on this. Rami, what do I do?
Use the merge method.
The merge method, yeah. So it turns out that when you have a hash, you can use a method called merge. So one of the very, very important things that I want you to do, three things off the top of my head that I want y'all to be thinking about this week. This is a slight segue. As you develop your programming skills, I want you to be thinking about scope, types, and control flow. So scope, right? Scope is knowing what variables or data are accessible from where you are in a program. At a particular point in a program, there are some set of variables that you have access to, and those are variables that are in scope. Things that give you name error, those are variables that are out of scope. So I want you to be thinking very hard this week as we start working through stuff about what data is in scope at a particular place in a program. And we'll talk more about it. Don't worry, I will talk more about when things are in and out of scope. I want you thinking about what type of data you have. If you ever have a variable, one of the questions you as a programmer should be able to answer about it is, what kind of object is it? What kind of data is it? Right? Is it a hash? Is it an array? Is it a string? You should know. Because what kind of object it is determines what you're allowed to do with it, what methods it will successfully answer to. Right? So if you don't know what kind of data you have, you're going to be kind of stuck. And finally, control flow is any sort of question involving loops, conditionals, method calls. When I think about control flow, I'm thinking, where does the program go next? When it finishes doing whatever it's doing right now, where will it go afterwards? And what must have happened for it to get to a particular line? How did it get here? Those are questions about control flow. Those are all things that will follow you whether you're writing Ruby, whether you're writing Python, whether you're writing JavaScript, or Lisp, or Haskell, doesn't matter. Those are things that are permanent, that are always around. Those are very important things to always be thinking about. So me right now, I'm thinking, okay, I've got two hashes, so I can use methods that hashes have. And one of the methods that hashes have, right, that's my data type. I've got hashes. And one of the methods that hashes have is a data type or a method called merge. So when we are using merge, the way it works is that I have a hash. That's what example is, right? It's the kind of thing that I have. I can call the merge method on it, and then I pass in as an argument to merge another hash, some additional hash. So if we're thinking about the dogs that I have, I've got a dog named Selah, and she's just perfect. She just does everything right all the time. Selah never does anything wrong. She's wonderful. She's a very sweet girl. And so if I try to merge this hash that says Selah is perfect into the example hash, which says that Jürgen is naughty, I'll get this. I will get, as a result, a hash that has Jürgen as naughty and Selah is perfect, right? It just combines the two hashes together. That's what merge does. That's exactly what I want to say, take some home players and some away players, put them together to get a list of all the players. So that's very, very handy for what I'm doing right now. Couple minor notes to make about merge. It doesn't modify the original object that you call it on. So if we look here, I've got, if we look at example again, it's the same as it was before. Does that seem kind of weird to anybody?
No.
Okay. So merge is what I would call a non-destructive operation. It doesn't mutate the original value, right? If I say example.merge, it's going to produce a new value, which is the combined thing. But if I want to hang on to that, I've got to store that in a variable or return it from my method to whatever called it so that they can store it in a variable and use it, something like that. It's not modifying that example in a permanent way. It's building a new thing, right? It builds a new hash for me to use. So that's a minor thing to note about merge. Okay. So I think that will solve my problem, though. I think I could do something like define a variable here called allPlayers. I can say homeplayers.merge away players. And then that hopefully will put those hashes together, give me some completed hash that has all of them. Let's see if it works. I'm going to exit to test it. I exited. because I need to rerun the code based on the change that I made, right? So I made think about my process here. I did some experimenting to find a method that was helpful to me. I wrote an additional line of code, just one line of code defining a variable. So simple. But to test it, I'm going to exit pry. I'm going to rerun my RSpec tests so that they run the modified code. And then I'm going to check to see that the output is what I expected. I expect to look at this all players variable and see a list of everybody now, not just the home players or the away players. And it looks like that's what I got. It looks like I've got everybody now. So I'm in good shape. So merge did what I wanted. I'm happy. Feel very smart. What a programmer. Okay. Cool. Questions?
You just typed exit to get up.
Yes. So there are two different things you can do. You can type exit when you're in pry, and that'll get you out. But sometimes you have binding.pry in a loop, like you're inside each or map or something like that. And if you're in that scenario, you're going to exit, but the program keeps running afterwards. And so you might then go into the next iteration of the loop and then wind up right back in binding.pry, which is unfun. One other trick you can use in those scenarios is just to do triple exclamation points. That basically says, leave, don't come back, kill Ruby, I'm tired of all of this, please make it stop.
Control-C also is
So Control-C is an interrupt. It sends a signal from the terminal to whatever program is running, which is an interrupt signal that basically says you should stop now. Sometimes that does nice things, and sometimes your terminal can get a little gunky. So I try to use exit or the triple exclamation points. But Control-C is great for just stopping a program in general.
Yeah, I think I got caught like an infinite loop and then I had to Control-C.
Yeah, it can be very good for that. Cool. Keisha.
So when
Rose.
we did-
Sorry.
When we did home players and away players, we assigned those to variables. Was that like a necessity, or is that just because it's cleaner?
Definitely not a necessity. At the time, I didn't have the merge ready in my head. So Rose asks a great question, which is like, well, do we need these variables now? Do they really matter at this point? And the answer is no, we totally don't have to do that. Now I think it makes the code read nicely. I think it kind of looks clean. But we also could have done this instead. We could have written this. We could have said all players equals game hash home players dot merge game hash away players, like that, and that would have done the exact same thing.
So this is when we would just come back and optimize it.
Yeah, so this is a stylistic question, right? If you get the test passing and you get the code working, do you have a preference? It's up to you at that point. What do you think readability is? We can have some good arguments in here about what readability is. The more important point for me for y'all to be thinking about, because minor readability concerns aside, these two code examples are equivalent and the same. There is something very valuable about your observation, though, which is we're free to substitute in the values of variables into some other expression, some other line of code, and know that we'll get the same result. And I think that's really, really important. You can do that in algebra, right? If you have some, I know not everybody loves algebra, that's okay. But if you remember, one of the things from algebra that's actually kind of nice and winds up being kind of nice in programming too, is that if you have something like 3x plus 5, right? And you know the value of x, then you can actually just write in the value of x and say, okay, well, if x is 7, then 3 times 7 plus 5 is 26. Right? 3 times 7 is 21, add 5, that's 26. You're free to substitute in the values of things. And I think we should be free to do that in our programs at least a fair amount of the time. Right? There should be some rules around that, probably. That kind of goes into my stuff about control flow. We should be able to make observations about how programs work in a holistic way, hopefully. So yeah, it's a good observation. So we've got all the players now. And I will stick with the earlier version of the code just because I like the way it's broken up, but you absolutely could have substituted in those values, would have been fine. We've got a list of all the players now. Next, it says we're supposed to find the player whose name matches the argument player name. Well, that might actually be pretty straightforward. Now, at this point, you might be thinking, okay, I've got this list of all the players, and there's some particular player name that the method was called with. Looks like it's Jeff Adrian. and Jeff is in the list of all the players. So here's what we'll do. We'll say all players.each, and then as we're looping, when we do .each, what are we going to have here? What are we going to have as the argument to the block variable? Name and what? Key and wait, who said key and value? Yeah, sure. A key and a value. So this is kind of an interesting thing. I don't know if y'all have seen destructuring before. Have y'all seen this?
Yeah.
Okay. So when you're looping over a hash, you can destructure on it. If you actually do this, if you say, whoops, sorry. I'm looping over the hash with each. I'm saying I'm going to run some snippet of code with each piece of data. And inside the block, I get to give the piece of data a name, right? If I just use a single variable, it's kind of a weird thing about each. Really, it's a weird thing about working with hashes. If I just use a single variable, data, what I get there for data is an array where the first thing is the key in the hash. So for example, Alan here. So the first thing in the array would be the string Alan. And the second thing would be whatever this hash is of his stats. That's what I would get if I just use a single block argument, data. And that's super inconvenient, right? I don't actually want an array. I'm not really interested in the array. So the more common thing to do is to say, okay, I actually want two things. This is something we can do with each if we know that we're looping over a hash. We have to know that we have a hash. If I don't have a hash, I'm not going to get an array here, and I won't be able to break that into separate pieces. But this is called destructuring. When I have a block like this, and I've got an array, I can say, you know what, I know there are two things in the array, so just go ahead and take it apart. I want to give those individual inner pieces names. They're the stuff I care about. So I can say the first thing, Alan, is the key, and the second thing, whatever this hash of stats is, that's the value. So key and value are generically what these things are, but name and stats might be better variable names because they're more descriptive as to what data I actually have here. I've got a name, and I've got some stats. So I can say, okay, we're going to loop over all the players, and with each one, we're going to grab the name, grab the stats, and then I'm only interested in one particular player. So if the name is whoever I was told to look for right now, if the name is equal to the player name that was passed in as an argument to the method, then in that case, I want to just return that player's stats, specifically their points. All right? And I need the return here because I want to stop the loop and exit the method with this value. And that's the real use of return in Ruby, is it's a control flow construct that says whatever you're doing, stop and leave the method handing back this piece of data.
I have a question about that.
Yes,
It's something
Decca.
that I found very inconsistent, where sometimes they make you write return and sometimes they don't make you write return. You can just type in stats points.
So, Decca says sometimes I can just type in stats points, and sometimes that doesn't seem to work. Why? This is a really great observation by Decca. The inconsistency isn't actually in return. Return always does the same thing. The inconsistency is in how Ruby decides what to return from a method. So let's talk about that for a brief moment. When we have a method in Ruby, let's say it defines an array of numbers. Sorry for the boring example. And then it creates some sum, which is equal to 0. And then let's say I loop over the numbers. Why am I doing this on the whiteboard? You won't be able to see that in the video. Hang on, let me finish this, and then, Deck, I want to circle back to your question. Is that okay?
Yeah.
All right, so if I do this, if I say, okay, we're going to loop over all the players, and if the name matches the player name, we can return the stats of their points. And then at that point, we are done, end. I think that is a reasonable way to try to do this. Let's actually write that code and see what happens. So finding the player, I can just say player equals, well, I won't do that. I'll do my loop, say all players.each do name stats, end. And then in here, if the name matches the player name that was handed into the method, then I can return that player's points. I'll just say right here, return stats points, like that. All right, let's see if this gets the test passing. Then we'll be green. We can think about how to refactor, how to improve things. All right, I got a failure. But it's a different failure for a different test, which means we got this to work. Now I'm getting an undefined method error for a shoe size method, which is a totally different thing to what we were just working on. We were working on points scored. That means our points scored test passed. We have 4 passing tests. That code works, which is great. Hooray for us. Now, Decca had a really great question, which was, why does it seem like sometimes I need return and sometimes I don't? It's inconsistent. I don't like it. Why? Excellent question. The answer is that in Ruby, if I have some code like this, the inconsistency isn't actually in return. The inconsistency is in how Ruby decides what the return value of a method is. And it's actually non-inconsistent about it, but it does seem that way. We have to think very carefully about it. So for example, let's say that I have some method that's just going to sum an array of numbers. And actually, to make this a less dumb example, maybe what we could do is say that it takes in an array of numbers and adds them up. So it's going to sum up an array of numbers. It's going to start by having the total be, there's a variable for total, and we'll just initialize that to 0. And then we'll loop over the array of numbers and say with each number x, we're going to add that to the total. The total will equal the total plus x. And then here I say end, and then here I say end, and I call sum of 1, 2, 3, 4, and I get back the array 1, 2, 3, 4. What in God's name happened? Well, there's one way to fix this. I can rewrite this code, but I can rewrite it saying at the end, total. Now I don't actually have to say, oh damn it, and then I make a typo. Now I don't actually have to say return. But what happens is Ruby's rule about what the return value of a method is that the last, what I'm going to call the last expression in the method determines the return value of the method. And so if we look at the earlier example we had, the question is, what's the last expression in the method? That's the thing that produces the result. In this version of sum, nums.each is actually the last expression in the method. And that might be a little surprising because, well, there are a couple reasons. It's not the furthest thing down. It doesn't appear to be at the end, right? But the reason for this is that nums.each is actually the last full method call inside of sum. There's no line afterwards. What distracts you, what makes it seem like that nums.each is not the last part, the last expression inside this version of sum, right, is actually the block, right? The block is what leads you to believe that this modification of the total is the last thing in the method. But that's not actually how Ruby treats it. When I see blocks, there's a way that I think about them in particular, which is that when I see a block, I think that I'm filling in a blank in some other method. So I think that there's this each thing, and it knows how to do looping, right? Each knows how to loop. But it needs to know what to do inside the loop as it grabs every individual item. And so I have to fill in the blank for each. But that means that when I see a block, I think of the block as an argument to each, or whatever method gets the block. I don't consider it as some separate kind of thing. I consider this me passing in some fill-in-the-blank argument, some snippet of code that gets handed off to each. And if I think of it that way, this code, this do end, the whole block, it's not really, I mean, it's part of my method, but it's getting passed to something else. And then it makes a little bit more sense that this would actually be the last thing that runs inside my version of sum. In this version, total is the last thing that actually runs in my version of sum. And so in Ruby, sometimes we want to stop early, and that's where return starts becoming interesting. But you shouldn't need it unless you have a block and you're doing some looping and you want to stop early. In general, Ruby's going to take whatever the last expression is in the method and use that as its return value. But it's a bit of a subtle thing. We'll see some tricks with that as we go on.
So-
Rami.
So if we put return in the each loop, would it like stop there?
Yeah, so if we add a return inside the loop, in this case, it's going to stop on the first iteration. So if I do, let's just run sum with 1, 2, 3, 4 right now. See that hopefully that works. No, because I typed it wrong. Let's do this. Thank you, text editor. That was very helpful. And I can't type. Oh, God. Okay, so in this case we get 10. Now we don't actually need a return here because I can just say this value total is the thing that I want. So I don't need a return. If I'm able to put the variable on the last line and I expect to reach the last line, then that's great. If I need to stop the loop early though, then I need a return. In this case, if I add a return, the very first time we're looping through nums, we're going to hit that return. And so we should stop with what value, Rami?
1.
Yeah, we should just get back the value 1 because we're going to stop immediately after the first version.
So that's what
And
I was
what
wondering. How come sometimes it says put return and sometimes not? So it just stops. Return just makes it stop at that point.
Return makes it stop and leave with whatever values to the right of the return.
Oh.
So in general, if you can add the variable name at the end of your method or something like that, that's not an uncommon thing to see in Ruby. It kind of looks weird. I could add return here, and some people do, but it does nothing, right? There's no need to have return at the very bottom. At that point, Ruby's just like, well, I'm going to read this value of the variable and hand that back as the result. That's what it does by default. But sometimes we have a situation where we actually want to stop early and hand back a result. And when that happens, we need the return. It'll bail us out of loops. That's my thought process. Cool. Questions about that? We okay? All right, cool. Yes?
Why did you make the total equal 0?
I like to, if I don't make the total 0, then the variable doesn't exist. And once I'm in the loop, I can't add to it because I don't have anything yet. So I initialize the total to 0 so that inside the loop I can start putting more stuff in there. Otherwise, when I say total plus equals x, it's going to be like, well, what's total? I don't have a total. I'm going to get weird problems. Was there another question? I feel like I saw another hand.
I was like, thumbs up. I get it.
Cool. All right, great. Okay. Now, this is far from the only way to write this method. If we go back to TDD, we've got this process, right, of red-green refactor. So we had a test that was failing. It was red. It's now green. It's now passing. When I run the test suite, we now wind up in a situation where there is some failure, but it's a different failure than what we had before. So at this point, I have a choice. I can go on to the next method, or I can refactor. Does anybody think there's a way to improve this code?
Yeah.
What? What's your name?
Narendo.
Narendo. With a D?
Yes,
Awesome.
N-E-R-A-N-D-O.
Awesome.
So you could use a method that you took out, which is basically game-hash.home, well, symbol home, symbol players, .merge, same one away, and then you use the line from line 135 all the way down. So it would be like incomplete.
So I could refactor by pulling these, getting rid of these two variables,
Yes.
basically, pulling it all into all players.
Yes.
Yes, we could do that. That's true. I don't know that I'm particularly going to go through that refactoring, but I totally agree. Rhodes.
My thought would have been to just do all players and use that same bracket syntax to just get all the way down to wherever the points is and just throw in player name where we would have put the player's name.
I like it. I got this to work, but I had to use a loop to do it. It's always going to be simpler to not use a loop than to use a loop. And generally, This is how it is. And generally, if you have a way to directly get the data you want, then why loop checking for that data? Right now what I'm doing is I'm going through every single player in the list of players and saying, well, is this the one I want? Is this the one I want? Is this the one I want? I know the one I want. It's that. Well, if I already have a hash and I can look things up in a hash by name, that's the whole point. Hashes are sometimes called, they're in the category of associative data structures because they associate keys with values. Well, I have some information that I can use that basically is the key that I'm looking for. I'm looking for Jeff Adrian, or I'm looking for whatever player name happens to be, right? That's the key. So if I have that, I don't really need the loop. I should be able to get rid of the loop. I should just be able to say, you know what? These are all the players. The specific player I want is all players for that player name. And now I will use the variable because player name isn't a symbol in the hash or a string in the hash that I want. It's some other value that got passed in.
Okay.
And I want to read that value to get the string that it holds and use that as my key. So now I've got the individual player. Once I've got that individual player, then I should just be able to return that player's points. Player points. And then all of this code can go away. And I just have that as my method, right? I don't need the loop. I don't have to have it. And that's a refactoring I like because the resulting code is clearer, feels cleaner, feels simple. Simplicity wins. The simplest solution that can possibly work is usually a good one. Yes, Naranda.
Flip back, let me see the previous screen.
Yes, absolutely.
So I cried for 3 hours for 2 lines of code. Okay.
So even though the player name that is given is not going to be in the form of a symbol, it's not going to have like colons anywhere, it
Yes.
still can understand it and match it up to the argument we're passing it.
It can, and so this is where I really like kind of that thinking of this as almost an algebraic or algebra kind of thing. So if we look here, we've got this num.sort method, right? And it's taking in an argument of player name. Now, I don't know, looking at this in the abstract, I don't know what that is. But I get a much better idea when I run the tests because we see some test failure and we see if we actually go into the test file and have a look at it, which is sometimes a good thing to do, right? Let's go into the test file and try and figure out what they're doing. We can see right here that they run it always passing in a string for a player name. So I know that player name, that value should be a string of a player name. Now, if we think back to this principle, I like to call this substitution. If we think back to this substitution principle, that means that inside the method, player name is some string. And whenever I see a line of code like this, the question we really should be asking, to Tiffany's point, is like, well, how does Ruby run that code? Sometimes I call this evaluation rules. In what order do these things happen? That's really important to be able to suss out, right? Really important to be able to know. Excuse me. And so the way I think about it is, whenever I see an assignment statement, like we have on line 135, I assume that the right-hand side, to the right of the equal sign, is going to run first, and it's going to generate some value, and then a variable will be created with the name on the left-hand side, and the value will be stored into that variable. Right? Because a variable is just like a box, right? So I assume that we're going to create a box with that label, run the right-hand side, and put the result in there. Now thinking about the right-hand side, all players, and then indexing into it with the brackets and player name. Here's how I think Ruby has to run that code. I think first Ruby has to look up the value of all players. It knows that that's some variable, so it goes and looks it up, and it sees that there's a big hash. And then I'm going to say something that's going to sound completely insane, but is actually true, and we'll talk much more about it on Wednesday, one of my favorite lectures in Mod 1. This bracket syntax, that's actually a method call. That's actually running some method on a hash that looks up the value of something in the hash. And if that's a method call, it's got to evaluate its arguments first. So let me talk about that. And again, evaluation rule is super important. So it turns out, let me actually throw a binding.pry right here on line 135. There it is. if I've got this object, we know that this is a hash, and we're used to looking at it by accessing keys of it by using the bracket syntax and passing in a key like that. But to my earlier point, that this is actually a method call, and this is going to seem really weird, deep breath. It's also totally fine for me to do this. You will never see Ruby programmers write this code. We'll talk a lot more about why this actually works on Wednesday. This is consider this a preview.
That actually makes a little
This
sense
seems
to me.
very magical, but there's actually some sort of square bracket method that accesses stuff inside a hash, and we're giving that an argument of a player name. And so if you think about it, it's got to now read that value. Whenever you call a method, I don't care what method you're calling, right? That's got to do the same thing. Whatever method you're calling, if, for example, I have a double method that just takes in a number and doubles it. And I say double 5 plus 7. Now, the answer that we should get for this is 24. But there are two different ways that could work. There are two different orders in which that could be substituted. I could either, wait, what?
What just happened?
You can
Do
put
a
it
plus
plus
sign.
You meant to put times and you didn't put.
No, I did not mean to put times.
Oh.
So why
I'm
can't you
gonna,
double?
I'm not sure why that's happening. I literally have no idea what the hell just happened. I've been programming 15 years. Congratulations, this happens to everyone. Here, we're gonna do this instead. Narando, yes.
I was looking at it and I'm wondering if it's because it's returning double as the function name, probably?
What if you parenthesize a 5 and the 7?
Why did it work the second
Again.
time?
Then it would be a string.
I don't know.
It did not work the second time. I asked it to,
What?
Yeah, look.
12
12 times 12 is 144.
oh, it's squaring.
Ah,
Yes.
I wrote the square function. So I'm a wizard. You know what? It's a Monday. That's what I'm just going to chalk it up to it's a Monday. There. That's how you should double things, right? Multiply them by 2. That's doubling. All right. I feel better. Yeah, the code worked. I did not work. The code worked fine. Okay. The point I wanted to make. Whoops. If I have some double method and I pass in 5 plus 7 and I get back 24, and what the method did is it does x times 2. It gets some argument x. We have to make a decision about how that's happening. Even though this is a very simple example, we have to decide, does it first add 5 and 7 to get 12 and then do 12 times 2? Or does it take this snippet of code and substitute it in for x and then wind up doing 5 plus 7 times 2 like that? That might seem like a really small thing, but that's actually super important. Does Ruby evaluate its arguments to produce a value before they get substituted in some other method or not? And the answer is Ruby will always evaluate arguments to a method first. The one thing that breaks this rule a little bit off the top of my head is an if statement. In an if statement, you only evaluate the condition, not the then or else parts. Otherwise, you'd be evaluating all the stuff at once, and that would kind of defeat the purpose. So if's a little bit different this way. But anywhere else, if we see a method call, Ruby has to run this piece first. That will produce some value, and then we can substitute that value into the remaining parts of the method. Right? And so the same thing is happening, the exact same thing is happening when we're dealing with some other method, like even something that seems pretty built-in and pretty fundamental, like accessing a value inside a hash. So when I'm calling this hash, we're looking up the value of the player name first to send that into this method call to look up some item in the hash. And so it's going to use the string, and everything's totally fine.
And again, you don't need variable.
And I don't need, wait, what? Which
You don't
variable?
need player. We could have just said all players.
Yeah,
player.
I could have said all players player name points. We could have broken it up that way instead. I'm keeping it this way mostly because it most closely corresponds to the pseudocode that was already there. But otherwise, yeah, you could refactor this in terms of just rearranging the parts in a number of different ways. The important piece of this refactoring to me was that we can just go directly at the data that we want rather than searching through all of them. Now, it's 11:29, which means I have about not that much time left, but let me answer a few more questions. Yeah, Rose.
When do you need
Drink.
to like, I don't even know how to say what I'm saying. The first time that I did this, because player name was a string, I did my quotations and my hash and my open brackets to try to interpolate it in and gave myself all kinds of, when do we need to do that and when do we not need to?
So
What is that just extra work?
because I already know the value is a string, and I already know the keys in the hash are also strings, I can just pass the variable like this.
As long as they match.
As long as they match. So there are probably specific situations that you're still going to hit where you get a bug. Talk to other folks about them. We'll get it figured out. Don't expect to never hit that problem. I guarantee you there's going to be some situation you run into in the next week where you're like, Britt, you told me if they're the same, I can just do it, and it didn't work. Why did you lie to me? And I promise when that happens, I will be able to explain it and I won't have lied. I promise. Hopefully I won't have lied. I don't know. Pretty sure. All right. We want to do one more method before y'all leave?
Sure. Yeah.
All right. I think we'll be able to work pretty fast. we seem to be cooking with gas at this point, so I think we'll be able to run pretty quick. So I'm going to take out my binding.pry. I actually wanted to see a test failure, not that. Get this out of here. Save. Run. Okay. So I'm getting a no method error. It says undefined method shoe size. Well, we know how to fix that. I'll say I need to define a method called shoe size. And that's all I'm going to write. I'm not going to write anything else. That should fix the error that I had. The error that I had was undefined method shoe size. There is now a shoe size method. I'll rerun the tests. Fail fast. Okay, so now it says argument error. Wrong number of arguments given 1, expected 0. Okay, so what does that mean? Well, it's telling me, I can see right here, they called shoe size and passed it something. That's the given 1. They ran the method and gave it one thing. It expected 0 things. So I need to add an argument to the method, right? So I'll come back here and say it looks like that argument, based on the example I have right here, looks like that argument's a player name again. So great. I'll say player name. Now I can rerun, and it says it expected to get back 18, which is a very large shoe. That's an incredibly large shoe. But it got nil, right? It actually got nil. So right now this method isn't doing anything. It seems like this is supposed to do about the same thing as the last one.
It's the exact same thing.
It's the same thing, except this time it's supposed to be points. Now, what I could do, right, is this. And then change this to that. Okay, all right. And then run fail fast, and boom, I'm on to the next method. Yeah, it's called shoe, not shoe size for some reason. I got lucky on that, but I just remembered because I've done this lecture too many times. If we look in here, it's actually just shoe, right? So that's why I just did shoe instead of shoe size. But then boom, it looks like it works. Okay, now here's the really important step. Red, green, refactor. We're now at green. I've got 5 tests passing, right? That shoe size test is no longer failing. I've got 5 tests passing. So that seems great. But now, I just copy-pasted code. And as a programmer, that always makes me a little bit dubious. There's a rule that a lot of people talk about called DRY. It stands for don't repeat yourself. As programmers, we try to define how to do things in one place, in exactly one place. And that's it's a pretty good rule. It's not a perfect rule, but it's pretty good. Most of the time, I don't want to repeat myself. So I'm now through red, I'm to green. I can think about refactoring. I can think about cleaning things up. And while this works perfectly fine, and it looks nice, it reads pretty well, there are a couple things that are off. First of all, I copy-pasted the comments, and these comments have nothing to do with this method, and they don't really need to be there. Second of all, this work is largely duplicated from the first method, right? Now, there are a couple different ways that we could try and fix that duplication. One is we could factor out this all players piece very easily to say, you know what, I just want a method that gets me all the players immediately, because that problem keeps coming up. Another problem that we could do, or another way that we could break it up, is we could say, okay, I want to factor out a method to get a specific player. Just look up a player, I don't care what team they're on. Either of those are perfectly fine. So if I was going to factor out all players, it would look something like this. I would define a method out here. And it would probably just grab the home players and the away players and then merge the two. And in this case, because I am returning, because this is like the last expression in the method, I won't even store that thing into a variable because it's just immediately going to get handed back anyway. I don't need to refer to it in here as all players or something like that, I can just say that's the last thing that happens, is that we build that value. And then elsewhere, I no longer need to have any special logic for how to do all players. I already have it. I can just say, yeah, just do all players, grab that. And then these methods simplify down to this, because I'm reusing that existing code. Right? I have this other method that already knows how to get all the players. And in these two, I don't have to worry about those specifics. All right. Now we could factor it a little bit more by also factoring out this piece. We could say, okay, I normally want to find an individual player. If I was going to do that, I might define a method like this. This is getting kind of abstract now, so if this starts feeling like a little strange or head-hurty or not following, that's okay. But I want to show this as an example just so we can try and step through it, think about how it evaluates, think about the control flow. Also, I'm now at time, so Pamela is going to show up any minute and be like, Britt, you stop talking. Okay, so the way that this should work is I would have a method called findPlayer, and it takes in a player name, and it returns some value.
What? You just slap the brackets on it?
All right, so let's think about how this works. First, let's see if this refactoring works. Let's make sure the tests still pass. So we don't know until we run it. Yeah, it looks like we're still on team colors, so I think it works. Okay, so let me talk through how this actually runs for a brief moment. If we look at this particular expectation, num point scored Jeff Adrian, I want to walk you through the control flow, okay? I'm going to walk you through the control flow of how this happens. So we call the num point scored method, and we pass in the value Jeff Adrian, right? So I come down to num point scored, and we have a player name, which is Jeff Adrian. Now, that method then runs findPlayer, passing findPlayer Jeff Adrian, string Jeff Adrian. So now we move over to findPlayer. It gets a value for player name, which is the string Jeff Adrian. That runs the allPlayers method. The allPlayers method builds some hash. We go into allPlayers right here, and it goes and builds some hash that has the complete list of every single player. And it sends that back, so we get it over here. Now we're back in findPlayer. We've got some hash with all the players, and we want to index into it to get some specific player out. And we do. So we read that player name, which is the string Jeff Adrian. We wind up with that subhash of stats, just the stats for Jeff Adrian. Those get handed back from findPlayer to wherever that was called. Right? So they come back here. Now we're at this point, and we have a hash full of stats, and we just say, I want the points out of that.
So it just replaces all of that with whatever the return value is.
Yes.
Good.
It replaces all of that with Now, the important point of this is that you can factor the foo out of things, and sometimes it's good and sometimes it's bad. There's a really great quote I saw once. It was called like the Goldilocks rule of programming or something. It was really silly and adorable. It was it basically was saying something like, for every programmer, 5 minutes, if you look at code that you wrote 5 minutes ago, it seems far too basic and simple, and you're like, why would anyone write it this way? There's such a better way. And if you look at code 5 minutes in the future, there's some code that someone else is writing where you're like, that's just way too crazy. Why would you write it that way? That doesn't make any sense. That's way too clever, right? You can go in either direction. Your level of comfort at any point as a programmer will determine what you find readable. That's fine. That's okay. If you prefer this style, where we just look up all players and then pull out some individual value for a single player and reference it here, and would never want to do this refactoring where you have some generic find player thing that then reuses all players, like if that's too heady, that's totally fine. It might be comfortable later. It doesn't have to be comfortable right now. But you can factor this a lot of different ways and go pretty deep into doing it. That's what I've got for our lecture today. I'm excited to do more with y'all tomorrow. I hope this was helpful. I hope this was helpful in thinking about some of the tools that you have. As you're going through this week, do think about how things are evaluating. Think about the order in which things are happening. Think about substitution, types, and scope and control flow. We're going to get more practice with all of those things throughout the week. Yes, what's your name?
Tony.
Thank you.
You mentioned that this lecture could be available online again.
All of these lectures will be uploaded to YouTube, and the code will be posted as well. We only got through a few methods, but that's okay. I will post all this stuff up, and then the link will be on your Learn dashboard.
Cool.
Other questions? Yes, Tiffany.
If this is a terrible question, you don't have to answer it. Just tell me to ignore
Totally
it
fine.
or whatever. But one of the things I kept running into doing the pre-work was my test would fail for some kind of reason outside of it actually even being able to run the test. And it was always because I didn't have enough ends, or I had too many ends, or I didn't have enough curly brackets, or I had too many curly brackets. Is there some trick I don't know to know how many ends or curly brackets are needed at the end of stuff? I mean, I'm probably not even asking the question properly, but maybe you know what I mean.
I had someone teach me a little trick.
Okay.
So that's something that I would love to talk about in lab time. One of the most important things for me as I'm writing code is making sure that as I use any construct in the language that requires an end, that I get one right away. So if I say def example, I'm going to put in an end before I write any of the code in the middle.
Sure.
So like I'm going to put in the end right then. Now I can come and fill this in. If I start writing an if 2 + 2 = 4, end. Then come back here, start filling in the other stuff. There are not actually that many things in Ruby that require an end. Off the top of my head, if, def, do, while, and, well, what the hell, we'll be talking about it Wednesday. Class. What? These 5 things always require a matching end. But there may be others I'm forgetting. While and until are kind of 2 sides of the same thing. So I'll do until. Each is really, the end isn't there for the each is there for the do. Anything that requires a block, the do requires a matching end. And when you're writing blocks, you're also allowed to write them with just curly braces instead of the do end syntax, in which case you need a closing curly brace. So we'll see more examples of that throughout the week. Yes,
I was actually going to ask, it seems in Ruby you can use the curly brackets or end. I was going to ask if there's any situation where you must use one or the other.
There is no situation where you must use one or the other. Using do end or using curly braces is a purely stylistic question. The general convention that most Rubyists seem to follow is that we will use the curly braces if we want to try and fit everything on one line. And if we're happy to break it up over multiple lines, we will use do and end. Cool.
Thank you.
Other questions? All right, thanks y'all. You're dismissed. Take a break and get some lunch.